Hello and welcome from the Royal Swedish Academy of Sciences, where we've just discovered who has been awarded the 2010 Nobel Prize in Physics. Joining me to discuss this year's prize is Professor Ingemar Lundström, the chairman of the Nobel Prize Committee in Physics. Professor Lundström, thank you very much for joining us.
Thank you.
Could we begin by you telling us who has received the 2010 Nobel Prize in Physics?
Yes, the prize was awarded to Andrei Geim and Konstantin Novoselov at University of Manchester for, as we said, groundbreaking experiments regarding the two-dimensional material graphene.
And so what exactly is graphene?
Graphene is actually, for normal people, the building blocks of graphite. The sheets of graphene makes up the graphite. So when we make a line of pencil line like that, we have probably produced graphene without knowing it, because graphene is the single monolayer of carbon atoms, and part of this pencil line would actually also contain a single monolayer.
So graphite exists as stacked layers, is that what you're saying?
Yes, it does, yeah.
And so, and graphene is one of those layers?
You're correctly, yeah.
Okay. And you have another nice prop to show us to show how graphene is...
If you like to get a feeling for what graphene is, you can actually increase its lateral dimensions with 100 million times, and then you will get the honeycomb or a chicken wire-like structure, which would be of this size, 100 million times larger than graphene. And actually, if we could show that, these lines would be about only 3% of the size of the thickness of this chicken wire net. And what is interesting is that the two researchers and the co-workers, they started out to use graphene flakes which are not bigger than the Drendaft you have in your hair. But today you can produce on plastic foils graphene sheets which has the same width as this net. So it's a tremendous development which has occurred in 6 years, because I didn't tell you that the groundbreaking discovery was made in October 2004.
Okay. So if we focus on that discovery in October 2004, could you tell us about how the researchers... Could you tell us more about how graphene was actually isolated?
Yes, it's a very interesting story. If I had a piece of Scotch tape here, I could have demonstrated it to you. But what they did was actually that they took a piece of graphite, a piece of carbon, they put the Scotch tape on the carbon, and since graphite can be easily cleaved, they got graphite on the Scotch tape, and then they by making this procedure many times, open and close the tape, they got thinner and thinner layers, which they placed on another substrate, which happened to be an oxidized silicon crystal.
And what's the importance of the oxidized silicon crystal?
Oh, that was the other invention they made. They found out that if they oxidized the silicon to a certain thickness of oxide, they could actually see single layer of carbon due to interference, changes in interference color. So it was a very, very ingenious way of actually spotting a single layer of graphene, which made it possible for them to isolate it and characterize it.
And so what makes graphene such a remarkable material?
Well, it's thin, of course, it's light, it's very strong, it's transparent, and it's also a very good conductor. That means that graphene is open for many interesting applications, but it's also very interesting material from a fundamental point of view, since it's the first truly two-dimensional crystalline material.
So could we go into those applications in more detail, please? What exactly can researchers do with graphene now?
Well, there are, of course, some very, very obvious applications where there already are other ways of doing it, but where graphene would be superior. Touch screens, for example, in solar cells, bendable electronics, for gas sensors being able to spot single molecules, and also recently it's been demonstrated that if you make a pour in a sheet of graphene, you can actually use graphene to sequence DNA, which may be another possible future application of graphene.
So could you take us through how that's actually possible with graphene to do all these applications?
If I take the last one, to sequence DNA, is the fact that when DNA molecule passes through the pore, you actually change the current from the liquid on one side to the other side of the graphene machine to change the conductivity, the ionic conductivity. And that can then be spotted. And since graphene is very thin, the idea is that you could differentiate between different base pairs, because there will only be one base pair passing the same hole at the same time.
So it acts as a sort of filter?
It acts as a filter which also gives an electronic signature.
And so how far are we with these applications? Are there any applications on the market, or are these just potential applications?
I would say that they are still just potential applications. I think the touchscreen application has come further, but they are still not only in the laboratories.
So we have the discovery of graphene, and it has all these potential tremendous applications, but there's still potential applications at this point. So what was it that satisfied the criteria of this discovery serving the greatest benefit to mankind?
Okay, I guess first of all, for me it's a scientific, physical breakthrough, being able to isolate a true two-dimensional crystalline material, the thinnest material in the Earth, or on the Earth. And the second is that there are enough potential applications at this early stage which make me convinced that graphene will find many commercial applications or uses in the near future.
And you mentioned in the announcement that the discovery was made 6 years ago.
Yep.
Relatively speaking, is 6 years quite a short time between discovery and Nobel Prize?
Yes, it is. Normally, I think there are longer periods, but if you go back in the history, you can find other prizes which have been rather early awarded. I should have a better memory than I have, but I think the scanning tunneling microscope is one of these occasions when the prize was awarded quite early after of the discovery, and also high temperature superconducting materials.
So given it's only been 6 years between discovery and the prize, and given that there's potential applications, there's nothing yet on the market, what made this such a strong case for the prize this year?
Actually, what I really said, it was the discovery or the isolation of the first true two-dimensional crystalline material, and a very large amount of already possible applications after only 6 years.
And of course, you could have given the prize to one person or to 3 people under the stipulations of the prize. What made you decide to give it to just these 2 researchers only?
Well, as you know, the deliberations in the Nobel Committee are actually kept secret for 50 years. So I think I will not answer that question in any detail.
But you said this is fundamentally for the paper that was published 6 years ago, and these were 2 of the researchers.
Yes, a groundbreaking paper, yes. And after that, Gaiman Novoselov has also contributed a lot to further knowledge about graphene. But the groundbreaking paper of October 2004 is actually the starting point for our discussion of awarding them the prize this year.
And just to clarify, the prize is actually rewarding that specific paper?
Not a specific paper. It's awarding the isolation and identification and characterization of the first truly two-dimensional crystalline material, which perhaps is more than that single paper.
And one thing you also mentioned in the announcement is that Andre Geim has also received an Ig Nobel Prize.
Right.
Does that make him the first person to receive the Nobel Ig Nobel double?
I'm not sure, because I have in the back of my head that there are people who have got the Nobel Prize first and have got the Ig Nobel Prize later, but that's not for me to say. But I think it's the first one who gets the Ig Nobel Prize first, and that the real Nobel Prize later.
And my final question is, have you had a chance to speak to both laureates?
Yes, we spoke to them by phone before this press conference, and of course they were both very happy and in different stages of shock. Geim was, I don't think, that shocked, but I think the Novoselov was quite surprised, quite shocked, and of course very happy. He happens to be the youngest Nobel Prize winner since 1973.
And how old is he?
36.
Professor Lundström, thank you very much.
Thank you.
Visit nobelprize.org to see more information about this prize and to listen to interviews with the new laureates. You can also receive news updates from nobelprize.org on Facebook and on Twitter channels. And for the very first time, you can submit your question to this year's laureates on YouTube. Visit www.youtube.com/the Nobel Prize for more details. We look forward to receiving your questions. That's about it from this live webcast. Join us tomorrow in the same room at the Royal Swedish Academy of Sciences, where we will discover who will be awarded the 2010 Nobel Prize in Chemistry. That will be at 11:45 a.m. Central European Time, but in the meantime, it's goodbye from all of us at nobelprize.org.